Okay, so we are going to talk about arc length and radian measure in this one. So let's talk about arc length first. What do you think an arc is when we're dealing with a circle? What do you think an arc is? Yeah, Annie? So semi would mean that it's half of a circle. So I'm going to be a little even more specific than that. Tori? Okay, so it could be the top part of the curve. It could be the bottom part of the curve. But what an arc is just a piece of the circle. Oh. So an arc is a piece of the circle. Now, when we want to measure the entire circle, what's that called? The outside of the entire circle? Circumference, right? If we want to measure the entire outside of the circle, it's the circumference. If we want to measure a piece of the outside, it's known as arc length. Okay, so it's still a distance, and we have a formula that we're going to use, but we're just going to measure basically the crust of a pizza or a pie. Okay? Now, before I give you the formula, I want to name a couple things. We called this the center before, right? That point. This angle here, anyone want to take a wild guess what that angle is called? If this point is the center? Central angle. So that angle that's attached to the center that creates that arc that we're looking for is known as the central angle. And I'm going to just label each of these points so I have something to reference. So I'm going to call it A, B, and C. This arc that we're going to be measuring, we're going to call M. So the arc that we're going to be measuring, we're going to call M. And M is equal to the central angle, which is going to be important for us. So if we know the central angle, we know what the measure of that arc is. Now, when we're talking about measure, we're talking in degrees. How many degrees is an entire circle? 360. So this would just be part of that circle. Okay? Now, our formula for arc length. Is the measure, so that piece over 360, because it's the piece of the entire circle, which is 360 degrees, times 2 pi r. Does 2 pi r look familiar? What's 2 pi r? Circumference. So really what this formula is saying is if you find the circumference and multiply it by just the piece that you're looking for, you'll be able to find the arc length. Okay, so we're taking a piece of that circle. Everyone okay with that? Okay. Our calculator does all the work for us, so you have to make sure, 1, you have a calculator, and 2, you know how to use it. So if you don't have one, take one out. If you need one, go grab one. Everyone good? All right. So I want to find the measure of the arc that I have highlighted there. I want to find the measure of the arc that I have highlighted. Now, if I look at my formula, there's two pieces of information I need to be able to plug in. What are those two pieces of information that I have to plug into this formula? What needs a value? Where can I put a number in this formula? The m, which is the measure of the arc. Do I know what the measure of that arc is? Remember that the central angle and the arc are exactly the same. So if the central angle is 60, the arc is 60. Okay, so that's my m. What else do I have to be able to plug in? The radius. Do I know what my radius is? What's my radius, Brooklyn? 12. So I have my radius and I have my measure, and we are literally just plugging it in. So 60 over 360 times 2 times pi times the radius. Now, just like with the last unit, we're going to have an exact answer and we're going to do a rounded answer. So let's start with our exact answer. What can I simplify before I start plugging too much into my calculator? Okay, 16 over 360. We can reduce that. What does that reduce to? 1/6. Okay, before I reduce that, can't we multiply here? So I really have 60 divided by 360 times 24 pi. Everyone okay with that? Okay. So in your calculator, here's what I would do. I know it's 1/6, but you can literally do 60 divided by 360. You have a decimal times 24. So don't clear anything and just do times 24. What'd you get? 4. So my exact answer would be, so for arc length, it would be 4 pi. What do you think my units are going to be here? Any guesses? I think I heard it in the back. MJ, did you say something? No? Are you sure? Any guesses on my units? If it's a piece of the outside of the circle, what do you think it's going to be? What's circumference? What would my units for circumference be? Wouldn't it be meters for circumference? This is the same thing. It's just a piece of that. So it's 4 pi meters. And then if I want an exact answer, do 4 times pi in your calculator and round it to the nearest tenth. What do you get? .6 meters. Okay, so you don't really do any math. You have to plug the numbers into the formula, and then your fingers have to use the calculator appropriately. I want you to try one. Can you do that? Okay. So I want you to find an exact answer and a rounded answer. All right. Do I know what my measure is, my M is? What's M? 90. Do I know what R is? It's 8. So if you know those two pieces, you can plug everything in. 90 over 360 times 2 times pi times 8. If I simplify this right here, I have 90 over 360 times 16 pi. So in your calculator, 90 divided by 360 times 16 should have given you 4. Yeah? So my arc length is 4 pi, what's my units? Yards? And I already know what 4 pi is multiplied. But if you want to plug it in again, you should get 12.6 yards. Did we do okay with that? Okay. We're going to add a layer. And we're going to talk about clocks. How many of you can read an analog clock? I see like 5 hands out of out of 35. Okay. So let's talk about a clock. I don't even know where to start. We know how to read it? Yeah. Okay. No. Well, good thing we don't actually have to read a clock, but we're going to talk about a clock. So we know, like, there's 4 main spots that split into quarters, right? 12, 3, 6, and 9. Do you agree with that? Okay. We're going to deal with the minute hand. Which hand is the minute hand? The long one. Okay? So if the minute hand starts in the center of my circle and goes all the way to the 12, what else is my minute hand going to technically be when I'm talking about a circle? If the minute hand goes from the center to a point on the circle, what is my minute hand? The radius. Okay? So we're going to look at this piece here. Now we're finding the length of the arc. However, we have to think about minutes that are involved. So how many minutes do I span going from the 12 to the 1? How many minutes is that? 15. Doesn't matter what the hour is. It can be 3 o'clock to 3:15, but it's a 15-minute span, right? Okay. So we know it's a 15-minute span.
You said going from the 12 to the 1.
12 to the 3.
Okay.
Did I say 1? I'm sorry. 12 to the 3. I'm sorry. Yes.
Especially if they don't know clock. So.
Yes. Sorry. 12 to the 3. Okay. Everyone okay with that's a 15-minute span? All right. Now let's just pause for a second. I'm going to tell you that the minute hand is 10 inches, so I know that's my radius. Okay. And if it's 12 or 10 inches here, it's 10 inches here, correct? Because it's the radius. Can anyone tell me what degree this central angle might be? 90. How do we know that? So if I went from 12 to 6, that would be half of my circle, right? Which would be what? 180. And so since this is a quarter of my circle, I know this is 90. Everyone okay with that? Okay. Now we have to convert minutes. I shouldn't write the 90 here. I'm going to actually write it here. We have to convert minutes to degrees so that we can appropriately do everything. Now, what if I didn't know this was 90? Here's how I can convert it. You guys know it's 90 because we can tell it's a quarter of the circle. We're not always going to be able to tell. So let's pretend like we have no idea this is 90 degrees right now. We're going to convert minutes to degrees. So you told me this is 15 minutes, right? From the 12 to the 3 is 15 minutes. How many minutes are in an hour? 60. So I'm going to say this is part of the whole hour. 15 over 60, right? Everyone okay with that? Now an entire clock is how many degrees? 360. So in your calculator, I would like you to do 15 divided by 60 times 360. And tell me what you get. 90. So if we can't look at our clock, let me fix this. If we can't look at our clock and say that's this degree, we can convert our minutes to degrees, giving us that measure that we need. Okay, so we started basic with this one so we can see it. The next one we're not going to be able to see as nicely. If I know the measure and I know the radius, can I find the arc length? Yes. So 90 over 360 times 2 times pi times my radius. Or 90 over 360 times 20 pi. So in your calculators, 90 divided by 360 times 20. We're stopping there for now. What'd you get? 90 divided by 360 times 20. 5? Did everyone get 5? So the arc length is 5 pi inches if I want it exact. If I want a rounded answer, what do you get? 15.7 inches. Okay, so again, this one was easy to see. My minute hand went from the 12 to the 3. I know that's a quarter of that circle, so it's 90 degrees. If it went from 12 to 6, it would be half the circle, it'd be 180, right? Well, what if my minute hand goes from 12 to 1227. And I will tell you that the minute hand is 6 inches. So I can't look at that and say this measure is however many degrees. I know it's going to be somewhere between 90 and 180 though, right? Because straight across would have been 90, straight down's 180. So how do I convert minutes to degrees? How did we convert the minutes to degrees?
What did you do in the last problem?
Okay, so how many minutes do I span total? 27. I go from 12 to 12:27. So I have 27 minutes total out of a full 60 if we were talking about an hour times 360. So 27 divided by 60 times 360 gives you what degree? 162. We said it was between 90 and 180, right? We know it can't be more than 180. Now that you know your degree, I want you to find the arc length. So you're finding this arc length. Take your measure, which is this here, so the 162, and take your radius and find the arc length. You should have 162 over 360 times 2 times pi times 6. Or 162 over 360 times 12 pi. If I want an exact answer, I'm going to get 5.4 pi inches. Did we all get that? Okay. And then my rounded answer. What'd you get for your rounded answer, rounded to the nearest tenth? 17. Good. 17 inches. I'm going to give you one that I want you to do start to finish. Can you handle that? Hopefully. That's 35, by the way. Okay. So there's everything you need. I want you to find the arc length.
If you're waiting for her to answer these, that means you're struggling with the process. So if you are, just let me know.
How many minutes do I span between 12 and 12:35? 35 minutes. So you should have started with 35 over 60 times 360. And what did you get? 210. Oh my gosh. 35 divided by 360. There we go. Okay, so 210 is my M, and my radius is 4. 210 over 360 times 2 times pi times 4 is 210 over 360 times 8 pi. And what did you get as your exact answer? 4.7 pi inches. And what did you get as your rounded answer? 14.8. Okay, so here's where our rounding comes in differently. Now, if I see what you plug into your calculator, I'm going to give you both answers. So if I plugged in real quick 210 divided by 360 times 8, I get it's hard to see. Oh, there we go. Right? I get 4.666 all the way to 7. So I rounded that to 4.7 pi. Now, if you clear your calculator and you do 4.7 pi, that's probably where you're getting 4.8. If I just go from here and say times pi, my answer is going to be 4.7. So I will take either one. If you put 4.7 or you put 4.8, I know what you did is the difference. If your decimal's way off from mine, then I know you did it wrong. Okay? But if you want an exact answer, don't clear your calculator and just multiply it by pi. So I'm going to write 4.7 inches. Or 14.7, excuse me. So yes, 14.7 or 14.8, I will take either of those. Okay, it's just the difference between something being a little more exact versus rounded. Do we feel okay about those problems? Okay, we're going to add one final piece to this. This last one's basic. Just put it on your warm-up page if you don't have room. So we're working in degrees. That's all we're really going to work in IM2, but we do want to introduce you to a radian, which is another form of measurement, which you'll see more in IM3, and then if you get to pre-calculus, there's kind of a new formula. So it's m over 360 times 2 pi. So we take out the radius. So m over 360 times 2 pi, and we're literally going to do one problem because we're not going to go a whole lot into this. So if I tell you the degree is 60 degrees, where do you think you're going to plug that in? For m. So 60 over 360 times 2 pi. It says round to the nearest tenth, so you are plugging that entire thing into your calculator. Everyone take a second and do 60 divided by 360 times 2 pi in your calculator. And tell me what you get. Rounded to the nearest tenth. What do we get? 1. Technically 1.0. Okay, this is as far as this part is going. So you just have to be able to plug that into your calculator. I'm more concerned that you can find arc length and do these clock problems. There are 2 minutes left. Your homework will be on Google Classroom tonight.